LEGO trains have a special attraction. They combine the creativity of building with the excitement of motion. This experience can be taken to another level using the PFx Brick. The addition of special lighting effects, sophisticated motor control, and new for LEGO trains, programmable sound effects enable an entirely new play experience. In this second video, we'll discuss the details of setting up the PFx Brick to maximum effect for your LEGO trains. In this video, we're going to discuss four main topics. First, setting up how we use our remote control, then motor configuration, followed by lighting setup, and finally, setting up our sound effects. So let's get started with setting up our remote control. To operate our train, we have several handheld remote controls we can choose from. There's the dual jogwheel remote, the dual joystick remote, and the remote from the EV3 robotics platform. For this video, we're going to set up the popular dual jogwheel speed remote, which comes standard with many LEGO train sets. When we configure a remote, we can choose to set up actions for each of the IR channels 1 through 4. In order to keep our setup organized and easy to remember, we're going to use each channel to logically group similar functions. We'll use channel 1 for our motor and speed control, we'll use channel 2 for controlling lights, and finally channel 3 will be used for controlling sound effects. So let's start with setting up our motor and speed controls. We're going to set up our remote control as follows. The left speed wheel will be used for controlling locomotive speed, the left button will be used to issue a stop command, the right button will be used to toggle the direction, and finally we'll set up an emergency stop command when both the left and right buttons are pressed simultaneously. Before we set up our remote control actions, let's talk about the two main methods the PFx Brick supports for controlling motor speed. Bidirectional mode is similar to how the LEGO IR receiver behaves. When we rotate the knob to the right, the locomotive increases speed in what we'll call the forward direction. When we rotate the knob to the left, the locomotive speed decreases, but still in the forward direction. If we continue to rotate the knob, the locomotive speed eventually decreases to a stop. Continuing to rotate left, the locomotive starts to increase speed again, but this time in the opposite or reverse direction. Finally, if we switch rotation to the right, the locomotive decreases speed in the reverse direction and will eventually come to a stop again. Now let's look at unidirectional speed control. When we rotate the knob to the right, the locomotive speed increases in the forward direction. When we rotate the knob to the left, the locomotive speed decreases but still in the forward direction. If we continue to rotate left, the locomotive speed will eventually decrease to a stop. However, unlike bidirectional speed control, the locomotive remains at a stop. It will not change direction until an explicit command is given to change direction. In our configuration, we've set up the right push button to toggle direction. Now, when we rotate the knob to the right, the locomotive speed increases again, but in the reverse direction. Conversely, when we rotate the knob left, the locomotive speed decreases and can be brought to a stop again. Unidirectional speed control is similar to how typical model train controllers in other scales operate. The speed control knob controls absolute speed in both the forward and reverse directions. This method gives much better control of the train since there is no risk of overshooting speed control past the stop point and having the locomotive suddenly reverse direction at some indeterminate speed. The next motor topic to discuss is dual motor control. If you recall, our locomotive has been fitted with two train motor bogies. If these motors were connected to the LEGO IR receiver, each speed wheel would independently control each train motor. Unless perfect control of the remote is maintained between the left and right wheels, this would almost certainly lead to unsynchronized motor speed and direction. Alternatively, we could connect both train motors to a single output on the IR receiver. However, each train motor would share the same motor driver with half the drive power of a dedicated channel. Since we're using the PFx Brick, these issues are eliminated. We can easily assign the control of both motors to a single speed wheel on the remote. Before we set up the remote control actions, we should talk about speed steps or speed control resolution. The LEGO IR receiver only offers 7 discrete speed steps in each direction. This makes precision speed control all but impossible. The PFx Brick, on the other hand, offers hundreds of speed steps in each direction for high-resolution speed control. You can select as many speed steps as you want in each direction, including the 7 speed steps for compatibility with power functions. So let's configure our remote in the PFx app. We'll start with the left jogwheel increment and select Increase Speed for both motors A and B, and with 33 speed steps. We'll set up the left jogwheel decrement in the same way for decreasing speed. We'll configure a stop action for motors A and B for the left push button, and a toggle direction command for the right push button. Finally, we'll set up an emergency stop action for simultaneous left and right button actions. Another consideration for the control of two motors is polarity. If each train motor is connected as shown, they will proceed to move against each other in opposite directions. This is because each motor is installed with opposite orientation. We could swap the orientation of one motor to fix the issue. However, these train motors are installed in such a way that there isn't any space to pass the power function's wires except at the middle of the locomotive. Another remedy is to use the power function's polarity reversing switch. However, this requires buying an extra component and finding more valuable space inside the locomotive. Since we're using the PFx brick, the solution is very simple. We can configure one of the motor channels to have an inverted polarity with respect to the other. In the PFx app, we select Motor Configuration, uncheck Identical Motor Configurations, and we'll select Motor Channel B to have inverted polarity. The last topics for speed control involve two advanced features of the PFx brick: adjustable speed curves and acceleration and deceleration. Adjustable speed curves gives us two adjustments to motor speed behavior. One, setting of minimum speed or capping the maximum speed, and two, adjusting the shape of the speed curve to give more emphasis to speed control either at lower or higher speeds. The other powerful motor control feature is the ability to set independent acceleration and deceleration rates to simulate the inertia or momentum of a real locomotive. By adjusting the acceleration and deceleration factors, we can simulate different momentum factors and make the process of driving a train that much more realistic. Our next setup topic is lighting. We're going to set up our remote on channel 2 with the following lighting features. The left jog wheel will toggle between high and low intensity brightness mode for the headlights. The left button will toggle directional headlights on and off. The right button will toggle alternating flashing ditch lights, and will configure the right jog wheel as a global brightness control for all the lights. Finally, we'll repeat our emergency stop command for the left and right push button actions. The reason for this repeated action is so that we always have immediate access to an emergency stop action no matter which channel the remote is set to. We'll set up directional headlights first. Directional headlights illuminate depending on the direction of travel of the locomotive. In the forward direction, we want our front lights to illuminate, and in the reverse direction, we want our rear lights to illuminate. The PFx brick lets you configure options for each light channel that implement this directional behavior automatically. Let's configure our left push button. We'll choose an individual light action for on-off for light channels 1, 2, 3, 4, and we'll select the toggle behavior. Under options, we have several choices for directional light behavior. We'll choose odd motor A reverse. What this means is odd numbered light channels in our selection will illuminate only if motor A is in the reverse direction. Conversely, even-numbered light channels will remain off. We are also going to add the same directional light setup as a startup action. Startup actions are performed automatically every time the PFx brick is turned on. This way, the locomotive headlights will turn on by default every time we turn on the locomotive. Next, we'll set up the high-low beam brightness toggle. We'll select an individual light action for the left jog wheel increment to set brightness. We'll select channels 1 through 4 and set the brightness to maximum. We'll repeat the setup for the jog wheel decrement, but with a low brightness setting. Next, we'll set up a flashing ditch light effect by choosing a combination light action of alternating flashers, and we'll choose light channels 2 and 4 for the flashing group. We can select the flash period, soft fade factor, and duty cycle of the flashing effect in order to fine-tune the appearance. Our final task is to set up the right jog wheel to behave as a brightness control. We are now ready to configure the PFx brick with sound effects to bring our locomotive to life. We'll set up sound effects on channel 3 of our remote control as follows. We'll assign sound effects which we used often, such as the bell and horn sounds, on the left and right push buttons. We'll use the left jog wheel to activate occasional sound effects such as compressor release noises and flange squeal sounds. And lastly, we'll assign the right jog wheel to be a volume control. Before we can set up the remote, we need to add the audio files for our sound effects. In the PFx app, we select the Audio Files tab and then add files to our sound file list with the Add Push button, selecting the file and confirming the audio format and quality. We can now set up the remote. We simply add audio playback actions to each remote control function just as we have done before. For sound effects like the bell, we can select a continuous playback action And for one-time sound effects like the horn, we can select a one-time playback action. And there you have it, the PFx Brick used to full effect to bring the same modern technology and operational features as other model train scales, by combining advanced motor control, lighting, and sound in one compact device. Truly gives new possibilities for Lego train builders everywhere.